In this lesson, we'll look at the equation of a straight line. The gradient-intercept form of a straight line is y equals mx plus c. The y must be by itself on one side of the equal sign. M is the gradient of the straight line. C is the y-intercept of the straight line. It has the coordinates of 0, c. That's where the straight line cuts that vertical y-axis. In these examples, we're going to look at what we have to do when we're given m and c, and we have to write the equation of the straight line. A straight line has a gradient of 3 and a y-intercept of -4. So m is 3 and c is -4. We look at the rule, we write it down, y equals m, well m is 3, x, and c is -4. Plus -4 is just -4, because a plus and a minus together become a minus. So the equation is y equals 3x minus 4. In the second example, we have a straight line with a gradient of -1/2 and a y-intercept of 3. So m is -1/2 and c equals 3. We look at the rule, y equals m, which is -1/2, x plus 3. Now sometimes it's better to write -1/2x like this. That way we know for sure that the pronumeral is in the numerator. But both ways are correct. In this example, a straight line has a gradient of -1/2 and a y-intercept of 2 1/3. Mixed fractions, we should change them to improper fractions first. So here m is equal to, well, how many halves in one whole? Well, there are 2 halves in one whole, so in 1/2 there are 3 halves. So that's -3 on 2. How many thirds in 2 wholes? Well, there are 3 thirds in one whole, 6 of them in 2 wholes, so in this fraction there is 7 altogether. So c equals 7/3. So we look at the rule y equals mx plus c. So we replace m with the fraction -3 on 2 times x, and we take c and we add it in, is 7/3. Now once again, just to make sure that we know the x is in the numerator, we often write it like this, but both ways are correct. Here a straight line has a gradient of 0 and a y-intercept of 3. So the gradient m equals 0 and the y-intercept equals 3. The equation of the straight line, y equals 0 times x plus the y-intercept of 3. And we don't leave it as 0x. 0 times x is 0. We don't need to write 0. So the equation is y equals 3. That's a horizontal line through y equals 3. In these examples, we're given the straight line's equation and we have to find the gradient and the y-intercept. Here we're looking at ones where y is already by itself on one side, the equal sign. So all we do is directly compare with the equation y equals mx plus c. If we put it underneath y equals mx plus c, we can see here that m is the number in front of the x, 3, and c is the other number, which is -1. So the gradient is 3 and the y-intercept is -1. Here the equation of the straight line is y equals 5 minus 2x on 3. Now if we compare to the original equation, the number in front of the x is the gradient. So the number in front of the x here is this one, -2/3. So the gradient equals -2/3. The other number is the y-intercept. So here the y-intercept is the 5, so c, the y-intercept equals 5. In this next example, a straight line has an equation of y equals 2x. We compare it to this form up here, and we can see that the gradient is the number in front of the x. So here, the gradient is 2. Now, there's also no other number. Well, that means the y-intercept is 0 because there is no other number there. In these examples, we have to find the gradient and y-intercept from the equation, but this time we're going to have to use the rules to equations to get y by itself. Remember that these rules are: if you change the side of a term, you change its sign, and when you multiply or divide, you must do it to every term. So in example 8, a straight line has an equation of 5y equals 3x minus 10. Now the gradient is not 3. The y-intercept is not negative 10 because the y is not by itself. It's being multiplied by the 5. So divide this by 5, divide that by 5, and the 10 by 5. Now these 5's cancel out, which is what we wanted. That leaves y by itself. And we can see 3x over 5, we just leave it like that, that's that fraction. And 5 goes into 10 twice, so a positive divided by a negative is a negative. Now we can compare it to the rule y equals mx plus c. The number in front of x is 3/5, so the gradient is 3/5, and the other number is the y-intercept, which in this case is negative 2. In example 9, a straight line has an equation of x minus y equals 12. Y is not by itself. So let's move this x. We're going to take this x and change its side, so it becomes a negative x over here. So I'm left with negative y equals 12. Now that's still not y by itself. I have a negative y. That's actually a negative 1, remember. So if I multiply every term by negative 1, what's going to happen is that's going to change the sign of every term. So that becomes a y, that becomes a negative 12, and the negative x becomes a positive x. Now we compare it with y equals mx plus c, the number in front of the x. And you might think, oh, there's no number. But remember, there's actually 1 there. We don't put a 1 in front of the x. So the gradient here is positive 1. And the other number is the y-intercept, which is negative 12. In the last example, a straight line has an equation of 3x minus 2y plus 8 equals 0. Now I could move the 3x and the 8 over, but I may as well just move the y term first. So I take that y term and move it over there, and it becomes a positive 2y. Divide everything by 2 to get rid of that 2 next to the y. The 2's cancel down, and that leaves y by itself. Now you can flip it over to the other side. It doesn't matter if you've got it by itself. We usually put it on the left. 3x over 2, and 2 goes into 8 4 times. Comparing to the rule y equals mx plus c, we can see the gradient is going to be the number in front of the x, which is 3 on 2, and the y-intercept is the other number, which is 4.